Hey everybody, here is our next lesson. We're on Unit 4, Lesson 4, Multiplying Rational Expressions. We just went over before today, obviously, how to find the least common denominator. And we did that so we could add and subtract our rational expressions together because you cannot add and subtract a fraction without having a common denominator. And now we're going to practice multiplying, and then next, after this, we'll do dividing, which is very similar. When we're multiplying, it doesn't actually matter if you have a common denominator. Just like when you're multiplying fractions, back when you first started in elementary school. I'm going to give you an example. So let's say you had this. So we first learned them. Remember, you just multiply across the top and you multiply across the bottom. And then you simplify. Those can both be divided by 2, and that would give me 1/6. Now, there is a faster way when you're multiplying. If you see that you can simplify something in the numerator and the denominator, even if it's not in the same fraction, you can do that before you multiply across the top and the bottom. And you see that here. These both can be divided by 2. If I divide this by 2, I get 1. If I divide that by 2, I get 2. And then I can multiply across top and the bottom. So 1 times 1 is 1, and 2 times 3 is 6. See, it kind of saves you a step there. You get the same thing in the end, but sometimes it can be a little bit easier to simplify as you go. And that's what we're going to practice doing with our multiplying. Up here at the top, it says multiplying rational expressions can be simple as it is the same process as multiplying numerical fractions, which I just showed you. The difference is that we will be using polynomial factoring to simplify and then distributing to multiply rational expressions. Just a reminder here, we did polynomial factoring in Unit 2. So all those notes are somewhere around, I think, the page 40 mark. I might have written it down somewhere before. There we go. Here we go. Look at that. Our factoring is page 43 to 50. At least the year that I recorded this, it was page 43 to 50. Obviously, if you change our page numbers, I'll put a note on quizzes if we change our page numbers for later on. Good. So yeah, 4 steps this time, pretty similar to what we've done so far. First step is still going to be factoring everything that we can and simplifying if we can. Step 2, instead of trying to make a common denominator, which you don't need for multiplying, it says here, if there are any matching factors in the numerator and denominator of any of the fractions, so just like we saw over here, it didn't have to be the same one. It could be a cross like that. There we go. You're going to cancel out. There we go. Anything divided by itself is 1. This is a really common thing that we forget, I think. When you're dividing, you're not just canceling stuff out. Stuff doesn't just magically disappear. It's dividing by itself, which ends up being the value of 1. Step 3, multiply across the top and the bottom to create one large fraction. And then step 4, find all values of x that make the denominator equal to 0. And the reason we're doing that is so we can identify where the function is undefined. And when you're undefined, it means you don't exist. Well, not you, but the function. You know what I mean. Here is our printed example. So step 1, factor all the polynomials. I gave us some space here to write that factoring down. Remember, when we're factoring something, we're always going to look first for a greatest common factor. And then if we don't have a greatest common factor that's not equal to 1, then we'll break into what kind of polynomial am I looking at. If I'm looking at a binomial like the tops here, I have 2 options. I can take out a GCF, or it's a difference of 2 squares. And then if I have a trinomial like on the bottom down here, I'm always going to do a multiply add chart. So let's look at this one. We have x squared minus 9. This is the difference of 2 squares. I know that because the first number is squared x squared, and 9 is a perfect square. So I'm going to rewrite 9 as something squared. And the square root of 9 is 3. So this is really 3 squared. When I break this up, the only way to get x squared is x times x. It's right here. The only way to get 3 squared is 3 times 3. And the only way to get this negative number right here is a positive number times a negative number. Okay, our other top here, this one is not a difference of two squares. I know that because 20 isn't a perfect square, even if 4 is. So I'm just going to see if I can take out a greatest common factor. These can both be divided by 4. You can see that right here. I divide out the 4. 4x divided by 4 is x, and then negative 20 divided by 4 is negative 5. Now, both of our bottoms are trinomials. Remember, when I have a trinomial, I'm still going to look for a GCF first, but if my front number is a 1, that GCF is going to be 1. So then I'm always going to do a multiply add chart. I'm going to multiply to a times c. So I have 1 times 25 is 25. And I'm going to add to b, which is negative 10. So I want to find the two numbers that multiply to make 25. That would obviously be 5 times 5. And add up to make negative 10. When you add numbers together, they're going to take the sign of the bigger number. So if they add to a negative, the bigger one is negative. In this case, they're the same size. And if they're going to multiply to a positive, they're going to both have to be negative, like that. And then you can see that right here. Remember, if it's just a 1x squared like this one, we can just automatically break it into our two factors like this. Have an x in the front because the only way to get x squared is x times x. And then put our numbers from our multiply add chart at the back. We'll do the same thing with this next one. I'm going to label this ABC. We're going to multiply to a times c, that would be 6. And add to b, which is 5. And that'd be 2 times 3. Again, this is a 1x squared, so I can just break it up into my two factors without having to do a box. X squared is x times x. And then remember, these two numbers go here. And there we go. Normally, you will not have this much factoring in one question. This example is a complex example compared to what you're going to be given all the time. We are expected to show you this level of rigor, but most of them are going to be easier than this just because I know this one was a little bit hard. Okay, step 2. If there are any matching factors in the numerator and denominator of any fraction, these will cancel out, and anything divided by itself gives you 1. So we're looking for anything that matches across the top and across the bottom. So I'm going to grab my highlighter and cross that out so it's not too hard to see. I have an x plus 3 on the top and on the bottom. I have an x minus 5 on the top and on the bottom. I don't have anything else on the top and the bottom. So then what you do is just write down what's left. So in this first one here, we have an x minus 3 on top and an x minus 5 on the bottom. And our second one here has a 4 on top and an x plus 4 on the bottom. Oh, sorry, x plus 2, my bad, on the bottom. And then we just multiply. We multiply across top, multiply across the bottom. So that would give me 4 times x minus 3 on top, and then x minus 5 times x plus 2 on the bottom. And that is the answer. Mark that there. And then here it says, lastly, find all values of x that make the denominator equal to 0. Solve each factor for x is how we do that, as that is where the expression is undefined. The reason it turns undefined is because you can't divide by 0. So what we're going to do, I'm going to put it over here, I left some space. So we're going to set each factor equal to 0. And we're just going to solve for x. And that'll give us our two, they're called restricted values. So I have x minus 5. To move that 5, I would just do the opposite. So I'm just going to add 5 to both sides. You'll notice you get the same number with the opposite sign. That's going to happen every time. Here I have x plus 2 equals 0. To get the x by itself, I would just do the opposite. So I'm going to subtract 2. 0 minus 2 is negative 2. And there we go. Okay, good. Let's look at this one. Like I said, they're not all going to be as hard as that last one. On this one, this is already simplified. That's already simplified. That's already simplified. This one, we can divide out a 7. And that will give us that. And if you want to rewrite, we can. We have some room for that. So right now we have p plus 7 times p plus 2. On the bottom, we have p minus 10 times 7 times p plus 2. So you can write it all as a big fraction like this immediately, or we can keep it how we did over here. You saw we like fully factored it and kept it separate. So if you wanted to keep it separate, here's what it would look like. I don't know if y'all can hear that. There is a massive windstorm outside, and it is so incredibly loud. There we go. We can also keep it like that. And then we're just going to cancel out. We have, if you have anything on the top and the bottom. So if you look at this second one, we both have a p plus 2 right there. Remember, anything divided by itself is 1. So on the top, I have p plus 7 times 1. So it would be p plus 7. And on the bottom, I have p minus 10 times 7. So that would just be 7 times p minus 10. If you wanted to re-multiply, you could to make that 7p minus 70. That is also perfectly fine. It's not a requirement, but I will offer extra credit on our practice if you do want to re-multiply. Now remember, we're going to set each of our factors in our denominator equal to 0. Here we go. Now that first factor is just a 7. 7 doesn't equal 0. So there is no restricted value coming from that. The only way you're going to get a restricted value, or where our function is undefined, well, if it was a function, or where our denominator is undefined, there you go, is when we have a variable in our factor, like the second one here. So p minus 10 equals 0. I'm subtracting 10. The opposite is to add 10. 0 plus 10 is 10. And there we go. So our restricted value, or where the function is undefined, is 10. And we normally call these RVs, if you want to call it that from now on. And there we go. Okay. Look at this one. This one does have a bit of factoring as well. So we'll do this one together, and then you can try number 3. Okay, the top here, this is a binomial. There's nothing I can factor out of that because x minus 2 is already factored, so that stays the same. This bottom here, we have 3x plus 15. Neither of those is a perfect square, but I could divide out a greatest common factor of 3 there. And if I did that, I would take out the 3, and that would leave me with x plus 5. Then our second fraction here, in our numerator, we have a binomial. Remember, our two options are greatest common factor, or it's going to be a difference of 2 squares. This one is actually a difference of 2 squares. We have x squared minus 1. 1 is a perfect square. It's 1 squared. So this is actually x squared minus 1 squared. Remember, the way we're going to write that and put over here, the only way to get x squared is x times x. The only way to get 1 squared is 1 times 1. And the only way to multiply this to a negative number is a positive number times a negative number. And there we go. And the bottom here, we'll put it over here. This is a trinomial. I know that because it has 3 terms. First, I'm going to look and see if I can take out a greatest common factor, but it says 1x squared at the front, so there's nothing I can take out. And I'm going to make a multiply add chart. I'm going to multiply to a times c, will give me negative 2, and add to b, which is negative 1. The only way to get to 2 is 1 times 2. And the only way to get a negative here is a positive times a negative. So I'm either going to do negative 1 and positive 2, or negative 2 and positive 1. Here it adds to a negative. Remember, when you add stuff up, it's always going to take the sign of the bigger number. So that's going to be a negative 2. But now that said 1x squared, so I'm going to do my little binomials here. We have x times x. And then we just take these numbers here from our chart and put them in there. So plus 1 and minus 2. And there we go. Now remember, I'm going to see if I can simplify. I'm looking for something that matches in the numerator and the denominator. It doesn't matter if they're in the same fraction or other fraction. So I have an x minus 2 on top and an x minus 2 on the bottom. Anything divided by itself is 1. And then I have an x plus 1 on top and an x plus 1 on the bottom. Anything divided by itself is 1. So now across the top, I have 1 times x minus 1. So that would just be x minus 1. On the bottom, I have 3 times x plus 5 times 1 times 1. So just stay 3 times x plus 5. Then again, if you wanted to simplify farther, you could multiply out that 3 to give you 3x plus 15. Like I said before, I'm going to give you extra credit on your practice if you decide to remultiply it out. And then to look for our restricted values, we're just going to set our denominator equal to 0. And it's all for x. That will never be equal because there's no x there. But this other one does have an x, so I'm just going to solve that. That's going to give me x equals -5. That would be our restricted value. What that means, if I were to graph this in a calculator, which I know we're not doing that right now, but if we were to graph it in a calculator, we wouldn't exist at x equals -5. It would have a vertical asymptote right there. And there you go. Good. So go ahead and pause, see if you can figure out number 3, and then come back when you're ready. Here is what you should have here. The only one that factored was this top here, this numerator. It was a trinomial, so I did a multiply add chart. I ended up with finding x plus 3 times x minus 5. And I wrote it down. And then you can see with the red is where I canceled out. We had an x plus 3 on the top and on the bottom. Remember, anything divided by itself is 1. And then here, I could simplify that. 8 and 4 could both be divided by 4. So 4 goes into 8 twice, and it goes into itself once. And remember, you multiply across the top and across the bottom. So I have 1 times x minus 5 times 2. We end up doing 2 times x minus 5. And then across the bottom, I have 1 times 1 is just 1. If your numerator is 1, that means you have a whole number, so you don't have to write it down. So our answer is 2 times x minus 5. Again, if you wanted to simplify farther, you could just say 2x minus 10, same thing. And then we don't have any restricted values because there's no value in the denominator that would make x equal to 0 because we only have a 1 in the denominator, and that will never be equal to 0. Okay, let's look at the next page.